Yes, welcome again on board. Hi viewers, here we go again with our KCSE 2023 qualifiers at number 19, and our question reads, straight line L1 has a gradient of negative a half and passes through point P, negative 1, 3. Then another line L2 passes through the points Q, 1, negative 3 and R, 4, 5. Then we are being asked to find Roman 1, the equation of L1, Roman 2, the gradient of L2, Roman 3, the equation of L2, Roman 4, the equation of L3 passing through point S05 and is perpendicular to L2. And lastly, the equation of a line through R parallel to L1. So this is a 10 question mark, and we can't afford to lose these good marks. So let's see how we go through it. So I'll just use a rough diagram. This is my L1, and L1 passes through a point P with coordinates negative 1, 3, and it has a gradient of negative a half. Then we are told another line L2 passes through the points Q. So I'll just draw it anyhow. Q and R. So Q, let me let this point be Q, which is 1, negative 3. Then R is 4, 5. That is L2. So the first question goes, find the equation of L1. So we have to assume another point xy along L1, and when we combine with the P plus the gradient given, we shall be able to get the equation. So we all know the formula of getting the equation of a line. We know from the perspective of gradient is usually change in y over change in x, and therefore now that we had let our xy with the point P, so we can substitute to form our equation. The gradient is negative a half. Now y minus 3 all over x minus 1. So cross multiplying, we shall be able to get, of course, negative a half minus 3 over minus is a plus, so we shall have x plus 1. Then I cross multiply now. 2 shall multiply the numerator on the other side, as negative 1 goes with the denominator on the other side. So I shall be having 2y minus 6 is equal to negative x minus 1. So completing our equation, we shall be having 2y minus x minus 1 plus 6. When 6 crosses this equal sign, it will change to be a plus. So finally, I will be having 2y is equal to negative x plus 5. Minus 1 plus 6 is plus 5. So I always tell my students, always leave your answer in form of y is equal to mx plus c, the general expressions of linear equations. So finally, therefore, this one shall be, I have to divide by 2 on both sides. So we shall be having y is equal to negative half x plus 5 over 2. Negative half x plus 5 over Q. So that is our equation of L1. So going to Roman 2, we are told the gradient of L2. So L2, we have 2 points. We have all the 2 points of L2. That is R4, 5, and Q1, -3. So the same thing, gradient is simply change in Y over change in X. So I can decide to use P as my point of origin. So I will be having 5 minus 3. That is Y1 minus Y2. The same to X. 4 minus 1. Then I will have here minus is a plus. So we shall have 8 over 3 as the gradient of L2. Gradient of L2. So having done that, we can go to question 3, the equation of L2. So now that we have the gradient, let's use the other page. Now that we have the gradient, so L2 with points, P, 4, 5, and Q, 1, -3. And now that the gradient is already known, 8 over 3. So we shall be able to get the equation. So that is the 8 over 3, which is the gradient, will still be y minus 5 over x minus 4. I've chosen point P with another point xy elsewhere along the same line. So at the end of the day, we shall have this. Cross multiplying, we shall be having 3y minus 15, that is 3 by the numerator, should also be equal to 8x minus 32. And therefore, collecting like terms, we shall be having 3y is equal to 8x plus minus is the minus of 17. Yes. So leaving our equation in the right format, we shall be having our y being equivalent to 8 over 3 minus 17 over 3. So that is the equation of L2. Going back to the fourth part, the equation of another line L3 passing through another point S whose coordinates are 0, 5 and is perpendicular to L2. So L2 and that L3, allow me to call it L3, are perpendicular lines. Those are lines that are crossing at right angle, and therefore we can remind ourselves there's a concept about them that says G1 times G2, that is the product of their gradient, should be -1. And now that we know the gradient of L2, which is 8 over 3 times G3 now, it shall give us a -1. And therefore, the gradient of the third line will therefore be -3 over 8. -3 over 8. That is when we multiply by the reciprocal. 3 over 8 on both sides. Finally, we shall remain with -3 over 8. So So using this, we can still be able to get the equation of L3. Now that we know it passes through point S with coordinate 0, 5. So we'll assume another point xy along the same line with the already existing points 0, 5. And the gradient is -3 over 8. So the same gradient can be expressed as y minus 5 over x minus 0. Cross multiply, we shall be having 8y minus 40, which is equivalent to -3x. Of course, -3 by 0 is still a 0. So our equation becomes, taking 40 the other side, it will be a plus. Then 8y becomes -3x plus 40 over 8 over 8 over 8. And our equation becomes -3 over 8x plus 5. This is the equation of L3. Then finally, coming back to the last part of the equation, we are asked to find the equation of a line through R and parallel to L2. So the line through R, we know coordinates of R, they were given here, 4, 5, and parallel to L1. And L1, we know the gradient was already given here, -1/2. So parallel lines have the same gradient. They have the same gradient. Therefore,